A few years ago I bought a cast iron surface plate measuring 2 foot by 2 foot or 610 by 610 millimeters square in a factory shutdown sale. Once I got it home, I never really did anything with it and it ended up going rusty under a bench for a while. Eventually I decided I ought to make a stand for it, so I dug it out and moved it to the workshop again. There doesn't seem to be any maker's mark or casting mark on it, although there is a number of some sort on one side, and as the tapped threads are UNC, I guess it might be American. Plate has 4 5/8 UNC tapped holes, 2 in one side and 2 in the opposing side, and I initially assumed they were intended for fixing it to a frame, and they might also serve as lifting points. I then noticed that the underside of the casting has 3 points where the sides extend slightly lower than elsewhere, these points forming an isosceles triangle when viewed from below. And it occurred that if the height of each were adjustable, then they could be used for levelling the plate. So 3 small plates to match these points were cut and welded up so as to support the surface plate. Each small plate to sit on the head of an M16 bolt to give height adjustment. So each plate would sit securely on the M16 bolt head. 3 steel rings were needed. So some 50mm diameter bar was drilled out in the lathe to a diameter and a suitable depth. But as the M16 bolt heads are 26.5mm diameter, it was easier to finish boring them out or drilling them out in the drill rather than do it on a lathe. Rings were then welded underneath the plates so that each could sit on the head of a bolt to provide adjustment and levelling. To take the 3 M16 bolts, 60mm lengths of 50mm diameter bar were drilled to the tapping size of 14mm on the lathe, tapped to M16 and welded onto a square frame made from 4 pieces of 5mm plate. A frame was then made up out of 40mm box to support the adjusters and take castors at the bottom and adjustable feet. Right. Eyes. Eyes. Great. Okay. One more leg. Four 5mm thick plates, each to take a caster and adjustable foot, were tack welded together so that the 4 caster holes and 1 adjustable foot hole could be drilled together, and then the welds ground off to separate the plates again. The 5mm plates were then welded to the bottom of the frame, and to support the adjustable feet, which are M16 thread and 150mm long, 40mm lengths of 30mm bar were cut, faced and drilled out to the M16 tapping size of 14mm. Each threaded boss was then tapped to M16 using a spiral fluted machine tap which, as can be seen here, ejects the swarf cut to make the thread out via the 3 spiral flutes. Not having used this Myford lathe for power tapping before, I had a bit of a fright when using the 3-position drum switch to go from forward to reverse at the tapping depth, and it slowed slightly as the lever went through stop, but then continued in the forward direction as the lever reached reverse. I then realised that unlike when using a 3-phase supply, you have to wait for the forward motion to stop before changing over to reverse with this single phase arrangement. Right. Threaded bosses for the adjustable feet were then bolted to the 5mm plates to align them and welded in position. The frame was then finished off with some small cross pieces to take a shelf at the bottom. At this point I should thank my friend John for helping me out with some of the heavier work when I wasn't quite up to it and just getting back into the swing of things. With the weekend approaching, it seemed a good time to paint the main frame parts. However, I never thought about joining the two together first, and I had to use the angle grinder to get back to bare metal so they could be welded together when the paint was dry. Right. I'll explain why I decided on using this setup for the feet and casters a bit later in the video. Just put the winch to the crane on it if you want. Yeah, that's right. Okay. So you got yours in? Yeah, I'll keep this one in. Yep. Oh, let's see. Right. Okay, hang on then. Right, try that. Down slowly. Okay. Right, that's in the slot. Oh yeah, it's not going anywhere, is it? Yeah. And it moves. But it doesn't move very well. The invoice for the casters states heavy duty, maximum 500 kilograms per set. So I expected them to carry the weight of the plate and the stand, which I guess is between 100 kilograms and 150 kilograms, or 200 to 300 pounds, without any problems. But as you can see, and particularly here, this didn't seem to be the case. The noise and rough movement, or sort of sidestepping, seemed to happen in combination with the casters not swiveling properly, when I expected them to be aligning themselves in a trailing fashion away from the direction of travel as casters do. The casters could be better. I can see them sort of sidestepping as I'm pushing it. That click, click, click noise is the caster. Of course, the term heavy duty, as given in the caster specification, is relative, and the ones used here are nowhere near as heavy duty as the ones I've used for my Myford lathe stand and benches. The casters on one of those benches can be seen in the background here. I had a spare set of these and thought about changing them over, but that would mean remaking the mounting plates. Then it crossed my mind that the casters on the surface plate stand seemed to click and not swivel properly when they were aligned with the mounting bolts. Though looking back in this video to when the frame was about to be taken off the workbench, they seemed to swivel properly then, but they weren't loaded then. So I used the adjustable feet to jack it up and have a look at the casters, and as you can see here, they seem to swivel okay, but again, there's no load on them. So I decided the only thing to do was try reversing the bolts. This would give more clearance between the bolts and the actual casters to see what happened. I did this for 2 of the bolts out of the 4 on one caster, and it seemed to make a difference. So I changed around all the bolts on all the casters, and this is the result, much better. The casters were sagging somewhat under the weight, and the gap between the actual caster bracket and the swivelling frame was reducing, and just catching on the ends of the bolts, turning them around was enough. So having solved the movement problem, we can now look at stabilisation and then levelling. I wanted to include adjustable feet to prevent it being easily moved on the casters once it was levelled. And when considering where to mount the feet, I could see that spacing them outside the frame would ensure they were easily accessible and would increase the stability of the top heavy plate and stand. Sighting them diagonally out from the corners would be best for stability, but on the downside would require a bigger footprint, and at the front would be a trip hazard. So I compromised by sighting them out to the sides. My kitchen cooker tackles the risk of toppling forward by using a short safety chain from one of its back corners to a wall fixing, and I may yet do the same for the surface plate stand, maybe using one of the 5/8 UNC threaded holes in the back of the plate. The 3 levelling bolts under the plate are sighted so as to be accessible from the front and the sides. So it's much easier here to show levelling by doing it in the middle of the workshop, where it's easily accessible and I can avoid blocking off the camera. To help illustrate the levelling process, I've left the main camera in front of the plate where all 3 levelling screws can be seen, and set up a second camera on a V-block overlooking my Starrett 98 level. This level is rated at 5 thou per foot, and the bobble moving 1 graduation equates to this, or as the plate's 2 foot square, raising the plate by 10 thou at one side will move the bobble 1 graduation. Sorry for mixing imperial and metric, but 1 turn of an M16 by 1mm pitch screw raises the plate above it 1mm, or 39.4 thou. For convenience, let's call this 40 thou. So in theory, a quarter of a turn in a verted adjuster will move the bobble 1 graduation on the scale, and this can be seen to be the case. I originally expected that after levelling the plate from side to side using the back 2 adjusters, I could then level it from front to back using the adjuster at the front, and that would be it. It actually proved to take between 4 and 6 cycles of repeating this, with the error getting less each cycle before it was done. This is probably down to the tops of the adjusters being standard bolt heads, complete with raised lettering, rather than being nicely smoothed and polished domes. I've left out the last few levelling cycles just to keep the video length down. Overall, once the caster mounting problem was fixed, as you will have seen, it's proved easy to move it, lower the feet to settle it, and then level the plate. Now it just needs a cabinet and some drawers in the frame to finish it off nicely. I'm quite happy with how this has turned out and impressed with the 3-point levelling system. I found myself using it quite frequently now for marking out. I hope it's been of interest, and thanks for watching.